Alright, let's practice some of the things that we have learned about our circles and see how we can do. So what I want you to do, I'm going to want you to work these 6 problems. So you're going to need to stop our video and work the problems. But then when you turn back on the video, I will work them with you or such that you can see what you should have gotten as your answers, okay? So if you will, just stop the video now and work these 6 problems, and let's see if you and I can get the same answer together. Alright, as we look at number 1, I'm going to use my figure and mark it up. If I were doing this as homework, me as visual as I am, I would have to redraw this figure every time. But, okay, number 1, we got OT. It has a length of 6. We have JO has a length of 10. And we're supposed to find JT. Now, the key to this is remembering that JT is a tangent to the circle. And that OT is the radius that intersects the tangent at the point of tangency. So it's significant to note that we have a right triangle. We have a right angle where that point of tangency is. So several of you by now can look at this problem and say, okay, well that means JT is going to have to be 8 because you have already memorized this as a Pythagorean triple. If not, though, and there's no reason to be upset if you have not yet memorized Pythagorean triples, they will come the more you use them. If not, you would have to set up that the 10 squared equals the 6 squared plus the length of JT squared. Okay, because 10 is the hypotenuse. So you would have to make sure the hypotenuse is on the side by itself. JT is 8. Okay, so that's what you should have gotten for the first one. Let's see what we should have gotten for the second one. Let's see if I can erase this. Alright, now let's remark our drawing. OT now is 6. I believe it still was. Now JT is 10. And we have to find JO. This is our unknown. I'm going to call it X. We still have a right angle in there at the point of tangency. So now, this time we would say that the X squared equals the 10 squared plus the 6 squared. Or X squared is 100 plus 36. X squared is 136. So X is the square root of 136. Now, I'm looking back at my directions. My directions do not tell me if I should leave in decimal form or if I should make this as accurate as possible. So I'm either going to pop that in my calculator and get a decimal, or I can see that 136 is divisible by 4. I'm going to try to reduce this. Let's see, 12, 16, 4. So I'm going to get 2 on the square root of 34 in simplest radical form. So my exact form for number 2 would be 2 root 34. That's exact form because nothing has been rounded off. But, and on a test or on a quiz, I'm going to tell you what to do with these, whether to put in exact form or if you can round, okay? So don't worry about that. If you have your calculator, everything is going to be good for you, okay? All right, let's look at number 3. On number 3, angle TOJ, so from T to O to J is 60 degrees. OT is still 6 units. We now have to find JO. Okay, now remember, we still have that right angle there. That's not going anywhere. So I've got a 30, that didn't do well. Let's try that again. A 30, 60, 90 triangle. And I know the short leg because I know that this leg has to be 30. And across from the 30 would be my short leg. So my short leg is 6. That's my short leg. It's not wanting to write at all, is it? Okay, I have the short leg and I need to find the hypotenuse. So the rule is simply you take the short leg and you multiply it by the square root of 3 to get the hypotenuse. So I've just got to put 6 on the square root of 3. And that will be my length for JO, and that's in exact form. One more with this drawing. Okay, JK is 9. KO is 8. We have to find JT. Now, please, as you look at that, notice again that we still have that right angle in there. That's not going away. If KO is 8, and that's a radius of the circle, all the radii in the same circle are the same, so OT is going to be 8. Now I have a situation where I can use Pythagorean. My hypotenuse is a total of 17. So I'm going to have 17 squared equals 8 squared plus the x squared. Okay, 17 squared is, I think I know that in my memory, but I'm going to just go ahead and check it out just to make sure. Yeah, it's 289. That's what I was thinking. 289 equals 64 plus x squared. 225 equals x squared. So x is 15. Some of you may have had that memorized. It's one of your Pythagorean triples. So JT is simply 15. Okay? Now let's look at the ones below there. We're going to talk about that ice cream cone effect, or that clown hat effect that we talked about. I'm getting the symbol to plug in my phone. To plug in my pen. Okay, the diagram below shows tangent lines and circles. We have to find the length of segment PD. Again, there's no segment bar across from PD, so that's telling me to find that segment length. Now let's look at the circle that has the tangent points A and B. That's our leftmost circle. Okay, so if I'm looking at this circle, if P to A is 8.2, then P to B is 8.2. Now we can focus on the second circle. If P to B is 8.2, P to C is 8.2. Have you already figured out where this is going? Now let's look at the third circle. If P to C is 8.2, then P to D has to be 8.2. Okay? Does that make sense? If not, make sure you ask me about that, because I want that to make sense for you. Let's look at the last one on this page. RS and TU are common internal tangents to the circles. If RZ is 4.7 and ZU is 7.3, find RS and TU. All right, if ZR is 4.7, then ZT is going to have to be 4.7. And if ZU is 7.3, ZS has to be 7.3. So if I want RS by segment addition, RS is going to equal to the RZ length plus the ZS length. So 4.7 plus 7.3. That's going to give me 12. And then I've got to add those same two numbers to get TU. TU is TZ plus ZU. So that's going to give me 4.7 plus 7.3. That's another 12. Okay, a good little review here for what we've learned. Just a reminder, all these pages that I'm going to be working to help you review in the next couple of videos that whole packet is in your Google Classroom. So you can go in there and get these sheets out without having to just rely on the video for the problems. The reason I want to look at number 17 on this page, and that's really the only one on this page I want to look at, is because it gives us another problem like one we had a night in our homework. And I just wanted to see or give you an opportunity to work another problem like this. So if you would, let's look at this number 17 and see. Well, first pause and see if you can work it, remembering how you did it in your homework. And then after you give it a shot, turn on the video and let's see if we agree. You can stop the video now. Okay, I hope you remembered how to do that, and I hope it wasn't very difficult at all. Let's see what we've got going. We've got JK tangent to both P and Q. So JK is a common tangent to two circles. We have to find the length of JK. So let's see here. I've got the length. There's J and there's K. So there's what I want to find. Okay, now, to do that, remember we put those radii in there and created a parallelogram. Let's do that again. If I put QK in, that creates a 90-degree angle, and since the radius of circle Q is 3, that length is 3. Okay, now let's put in the segment from P to J. That's a radius of circle P. Since one radius is 11, the second radius is also 11. Okay, now I'm going to come across here, and I'm going to come across here. And I have put an auxiliary line that goes through K and is perpendicular to PQ. Now, when I do that, I've created this parallelogram, and that means this opposite side over here is 3. So for that whole 11, 11 minus 3 is going to give me 8 for this segment. Remember that my right angle is right there at the point of tangency. Okay? We good with that? Now we know the opposite sides of a quadrilateral are congruent. So as I look down here at this side, I've got 11 plus 6, which is 17. So that means that this side is 17. So I'm really looking at, or looking for, the leg of a right triangle. Knowing that my hypotenuse is 17. Remember, this has to be the hypotenuse across from the right angle. So 17 squared equals 8 squared plus x squared. There's that 17 squared again. This is almost the same problem we had a while ago as far as the arithmetic goes. So the length of JK that we're looking for is 15 units long. Did you get that?